So if we use the definitions like how we did, synthesis means to make something, and decomposition means to break something down. Combustion, if we use that little two-word definition, means to burn. Or really what that's going to look like in any reaction is any substance combining with oxygen. So you will recognize a combustion reaction because O2, specifically O2 because oxygen's diatomic when it's by itself, will be a reactant. So I'm going to highlight these in orange because I think that makes sense with burning. So O2 will be a reactant in any of our combustion reactions. All products of a combustion reaction will have oxygen in them, and energy is usually released in the form of heat and light in this type of reaction. So if I start with element A plus element B plus O2, so I have multiple reactants combining with oxygen, the products that would form would be AO plus BO, because oxygen would be part of both products. Just old students. These reactions will usually produce a large amount of energy, but usually a catalyst is needed to start the reaction, so they need something to lower the activation energy, so that's where a catalyst comes into play. So for example, this first one, I have hydrogen and oxygen reacting together to form water. We could also read this as the combustion of hydrogen gas, again, to form water. That E that is released, this is just energy, so that's typically where you'll see like the fire. Example 2 says burning aluminum. So on a quiz or a test or any kind of practice, we could give you a question like this and say, I want you to write and balance the full equation for burning aluminum. And it might not sound like enough information, but you have everything you need. Because if you recognize that to burn tells you that that is a combustion reaction. So burning means combustion. And combustion means combine with oxygen. Then on my reactant side, I'm going to have oxygen and what element? Aluminum. So aluminum plus oxygen. I know it's going to be O2 because oxygen is diatomic. I don't put a 2 on aluminum because aluminum is not diatomic. So if I burn aluminum, what it's going to produce is the combination of oxygen and aluminum. So this is where your crisscrossing comes into play, where aluminum has a +3 charge according to our periodic table. Oxygen has a -3 charge according to our periodic, -2 charge, don't I write 3? -2 according to our periodic table. So when you crisscross it, what products do you make? Perfect. Al2O3. So we would call that aluminum oxide. So if you were to see this, the way we would read it out loud is aluminum combines with oxygen or burns in the presence of oxygen to form aluminum oxide. Then if we look at this in terms of what type of reaction is it, I knew it was a combustion reaction because I purposely made it that, and here is what shows me its combustion. Does it classify as any other types of reactions? It's a redox reaction. How come? What makes a redox reaction? Okay, the oxygen is a single element and the aluminum is a single element, so both of those would help it classify as redox. Anything else? Synthesis, how come? Because I have a single product, so my single product would make it a synthesis reaction. So we've got 3 different classifications for this. We have redox, because we have a single element. We have combustion, because one of those single elements happens to be oxygen. And then we have synthesis because we have a single product. So combustion and if you've put it together, all combustion reactions will be redox reactions because all combustion reactions, as definition, will have O2 as a reactant. So if you don't have O2, that's not going to be redox, or it's not going to be combustion. What did I want to show? Oh, oxygen as a reactant means specifically O2. So this one, for example, that we already balanced, O2 is a reactant, so this would count as combustion. But if I look at something that has oxygen as part of a compound, even though there's oxygen on my reactant side, that does not mean that it's combustion because this is not oxygen gas, this is just oxygen as an element as part of something else. So this is not combustion, but this one is. This one would also be combustion. And this one would be redox, and it would be synthesis for all the same reasons that this one was. Alright, last bit I want to cover is combustion of a hydrocarbon. So carbon and hydrogen, when you have them in the same compound, we call them hydrocarbons. So compounds of hydrogen and carbon. They always produce the same two products. You need to memorize this. I have yellow, I'll highlight that. Oh well, I'll use this one. So carbon dioxide and water are always the two products of combustion of a hydrocarbon. So combustion because I have oxygen. This is a hydrocarbon because it's a compound that contains both hydrogen and carbon. Is going to produce the same two things. First one, carbon dioxide, and the second one, water, H2O. Every single time. The E stands for energy. So it doesn't count as an element. It doesn't have anything to do with how we balanced it. We didn't balance this one, so that's alright. We can go back and balance it if you really want the practice. But I kind of wanted you to see the hydrocarbon part. Let's balance. We'll balance this next week. Let's do this one also. So similar to how this whole question was burning aluminum, right, and balance the equation, let's do this one, burning ethanol. So if I burn ethanol, that word burning tells me that's going to be what type of reaction? Combustion. Which means it's going to combine with oxygen. So I would take this reactant, C2H6O2, no, not 2, just O. C6H, I'm messing up my words. C2H6O, combining with oxygen, so plus O2, and the products that it would make are the same two things every time. So it doesn't matter how many carbons, how many hydrogens are in your hydrocarbon, it's going to always produce carbon dioxide and water. What's changing is going to be the number of carbon dioxides and waters. So if I have CO2 plus H2O. The reason I skipped balancing that one is because we've already balanced it actually on this page. So if you want to go through and balance it, it's going to be the exact same coefficients. But here it's going to be a little bit different. So if I draw my column and then I have carbon, hydrogen, and oxygen, on my reactant side I have 2 carbons and 6 hydrogens and 1, 2, 3 oxygens. On my product side I have 1 carbon and 2 hydrogens and 1, 2, 3 oxygens. So what coefficient could help us to be balanced? Okay, 2 in front of CO2. 2 times 1 carbon gives me 2 carbons. 2 times 2 oxygens gives me 4 oxygens from CO2, plus I still have 1 oxygen from H2O. So I have a total of 5 oxygens on my product side. What else? Okay, a 3 in front of H2O. 3 times 2 hydrogens gives me 6 hydrogens, and then 3 times 1 oxygen changes that to a 3. I would add the 3 oxygens from this 3H2O to the 4 oxygens I'm getting from CO2, so 4 plus 3 equals 7. So I have 2 and 2, 6 and 6, and then I have 3 and 7 for my oxygens. If I put a 2 in front of O2, 2 times 2 oxygens gives me 4 oxygens from O2, plus I have the 1 oxygen from here, so that gives me 5. Okay, 3 in front of O2. Is that what you said the first time? Oh, sorry, okay. 3 times 2 is 6. 6 plus the 1 gives me 7. Everybody's balanced. So then your coefficients would be just a 1, 3,